Hello and welcome back. Today we want to talk a little bit about finding the slope and driving an equation. This is something that we have talked about in class, but I want to give you a very specific and focused conversation on it. We will continue to talk about this. We'll continue to graph. We're going to graph all the time. But this is just in case you need a tutorial or you've forgotten or whatever. Okay, so remember that whenever we collect our data, we're going to graph it and then we're going to figure out the line of best fit, right? So ideally, we're looking to see, is it a straight line? Is it a curve, right? All of those things. And right now, we're just dealing with straight lines. We will do this again when we start talking about curves, okay? So we want to remember that not all of the data is going to fit on the line, okay? It just isn't, right? And that's the whole point of finding the trend. What we're interested in is not every single little point by itself. We're interested in what is the overall change? What do we see that is mostly common to all of them, okay? And so when we start doing this, you may have something that has a perfect positive or a perfect negative correlation. Remember, if y and x increase together, they are directly proportional. And if like one of them increases and the other one decreases, they are indirectly proportional. And so the one that is directly proportional will have a positive slope. The one that is indirectly proportional will have a negative slope. And then sometimes you get a strong correlation, like the trend. They're all doing kind of the same thing, as you can see in the second graph. Same thing with the negative. And then sometimes they're kind of all over the place, and your line is like, meh, kind of. And so we'll talk about this more if that happens to you, and same thing for the negative, okay? And then, of course, sometimes you have no correlation. You're like, I don't know how these data are related, and that's okay. I mean, you've figured out that that wasn't the relationship, and that's just as good sometimes as figuring out what you think the relationship might be. We'll talk about that more later on. Here is some real data with real trend lines. The idea is that you are looking at all of this variance because life is varied. And I picked this graph for two reasons. One, because I'm a life science person. I enjoy all of that. And two, to show you, especially in life science, that your data can be super messy and you don't really know. And so we've got all of these points, but we can see, oh, look, here's pretty much what we think the trend is in terms of, and this is about bioaccumulation. So the trophic level is the level on the food web. You don't really care about this for class, but just to give you an idea. And then what you have on the y-axis is the mercury load, methyl mercury to be specific, and that's how much mercury is accumulating in organisms as they go up the food chain. It's a thing called bioaccumulation. It's very cool. It's kind of scary. But what you're seeing is here, we're not having a really big increase, but look at this graph. Look at this line, this trend line. But if you just look at the dots, you have no idea really. I mean, you can get a sense that the bottom graph, C, is definitely increasing more than A, but you don't have a really good sense of what that means. And that's what the trend line does for us. It shows us very clearly this is the relationship we think. Okay. So when we look at these straight line graphs, we know just a little bit about graphing. Remember, you have your origin point, that's the 0, 0 point. You will have your x-axis, which has the independent variable. You have your y-axis, which has the dependent variable. The variable is the quantity we are measuring. It is measured in some units. Those are listed on the axis. This is all stuff we know, so this is part as a review, right? The stuff that was in the left side of the data table goes on the x-axis. The stuff that was in the right side of the table goes on the y-axis. Also, I mean, independent, dependent variable, that's more important. Then you plot your points, right? And they are showing some trend. You find the line of best fit. You will pick points that are on that line in order to calculate slope. All graphs have titles. That's a really important thing. All graphs have titles, okay? So now we've got our line. We see that it's a straight line, and that means that we can use the equation of a straight line, which is y equals mx plus b. Y is the y-axis, so you would put the variable that was on the y-axis there. M is the slope, which we're going to talk about calculating in a second. X is what is on the x-axis, and so you would put that variable there. And then if you have a y-intercept, Most of the things that we deal with in our class will not have a y-intercept, but it definitely happens. This is just where your line hits the y-axis. Does it have a value? Most of our things will start at 0, like in the gravitational force and mass lab. If there's no mass, there's no weight, right? And so that's true, but that's not always true. There are many instances where you actually do have some value above 0. But you don't have to worry about that now. So most of the time we will not have a b, okay? Ours will just be like y equals mx. All right, okay. So let's talk about the slope. This is m, right? And m is rise over run, all that good stuff. And so m equals y2 minus y1 over x2 over x1. You're going to pick points on the line that are actually on or as close to as possible, far enough away that you're in like the bottom third or you're in the top third, right? And so you want to get these 2 points that are on or really close to the line. You're going to use those to calculate their slope. The one closer to the origin is going to be 0.1. The one further away from the origin is going to be 0.2. And that is on the x-axis, by the way. Right, we're talking about on the x-axis. Okay. And so x1, y1, x2, y2. So how does that work? Okay. So let's have this. We've got all of our little lines. We picked ones that are on the line. I probably would have picked this purple one, but you know, it doesn't really matter because if they're all on the line, the slope should be the same no matter what happens. That's how slopes work. Yay. Okay, so we've got our x1 and y1, x2, y2, and then we'll take, it was 5, 7 and 3, 3. So y2 is 7, y2 minus y1, 3, x2 minus x1, 5 minus 3 is 4 over 2, and the slope is 2. So the slope of this line is 2. So we would put into there y equals 2x plus b. Now this one is a little bit different because it has an x-intercept. We're going to ignore that completely. I happen to like this graph from study.com, and so I'm using it, but we ignore the fact that it has an x-intercept. No. Okay. So let's put it into practice. We've got this leaking tank, right? Again, because I used to do environmental science, we do this sort of thing. But I think this will be nice to show you how it works to derive the equation, okay? So I'm going to flip over to my whiteboard and I'm going to write very messily on my whiteboard for you because my other pen is not working, which is very sad. So you can see here we've got our 2 points. So we're going to have one here, right? And I'm just going to write, oh, hello. Oh, let's do purple. Okay, so our x1, y1 is right there. That is terrible writing. I'll figure it out. This is x2, y2, right there. Okay, and so our m is going to equal y2 minus y1 over x2 minus x1, and that is going to equal, our y2 is 6, our y1 is 3, okay, and then our x2 is 8, and then our x1 is 4, and so we end up getting m equals 3 over 4, right? And this is a division problem that we have not done yet, right? And so we're going to take our calculator and we are going to figure that out. Yay! Okay, so you're figuring that out if you couldn't do it in your head, which is totally fine. But 3/4 is like 75%, right? So that would be 0.75. Yeah, what are the units? Okay, so remember it was y over x. Now, one of the things that I left out, and that is a terrible mistake, is the units. We can never, never, never leave out units. Okay, you always have to have units. So let's go back and fill those in because we realize we've made a terrible error. We didn't do it. But what's great about this is it's actually going to tell you what the units are because gallons here, and then this was divided by minutes, so this is 0.75 gallons per minute. Yay. Okay, so that's our slope. So now we go back, and what was on the y-axis? That was the amount. I'm going to call the amount n, right? And that's going to let us make this equation, because remember our equation is y equals mx plus b. Again, I apologize for the terrible writing. It's kind of like class, actually, right? Okay, so that is going to be n. Notice we did not put the units in here because this is all about variables, you guys. So then we've got our slope of 0.75 gallons per minute. And then we are going to have on the x-axis time. So that is t. Okay. Now, if this had a constant, if this was, well, this is a constant, it's a coefficient, right? And so if it was an actual, like, recognized one, like, whoa, my light just fell over. it's going badly. Is g equals negative 9.8. Whoa. Sorry about that. I had an incident. Okay. I pushed the wrong button. Okay, and so we've been doing newtons per kilogram, right, because that was our force. So that's why we had G in there. This doesn't actually have a notation of its own, because it's not a thing. It just happens to be for this. But this is the equation of this particular line, okay? So if you have any questions, please let me know in class or email me or chat me. And this was just a little how-to on the graphs. Again, we've talked about this in class. We're going to be talking about it more. This was just to put it all together for you in one directed place. All right. I will see you next time.